Instrumentation and control.
The electro-pneumatic action is a control system for pipe organs, whereby air pressure controlled by an electric current and operated by the keys of an organ console. Opens and closes valves within one chest, allowing the pipes to speed. This system also allows the console to be physically detached from the organ itself. The only connection was via an electrical cable from the console to the relay, with some early organ consoles utilizing a separate wine supply to operate combination pistons. Thank you.
There are three standard operational procedures, which is before, during and after. Before using the machine, number 1, ensure compressed air supply or hydraulic pump is in closed state, or make sure the compressed or hydraulic air valve is closed. Number 2, make sure all the hoses and components are organized and adequately and neatly installed. Number 3, ensure that all hoses, components and air compressors or hydraulic pump are in good condition and safe to use. Number 4, ensure the cable supply in good condition and safe to use.
While using the machine, first we have to turn on electric power and compress air hydraulic pump. This one. To the startup procedure is the reference to the practical implementation guide. We have to turn on like this. Make sure the machine work as in practical implementation guide. Number 4, input data related to the controller refers to the implementation guide. Number 5, make sure the other data is not changed on the controller.
Next, after using the machine, first turn off the electric power supply, turn off the compressed air and hydraulic pump. After that, empty the compressed air in the compressor tank. Damage to the supervisor or lecturer involved.
Troubleshooting a pneumatic system has been considered an art, a science, or just hit or miss luck. However, when reduced to its basic elements, troubleshooting a pneumatic system is a step-by-step procedure. Using this process can speed up the ability to determine what the problem is, the probable cause of the malfunctions or failure, and a solution. Safety should always be a prime concern of maintenance personnel. Compressed air is a volatile element in a pneumatic circuit. Air receiver tanks have exploded, causing severe injury to personnel and damage to property. It is imperative to relieve pressure in a recovered tank prior to making any repairs. Air is also highly compressible, which is another reason to be cautioned in the approach to troubleshooting a pneumatic system. When working with overhead loads that are supported by cylinders but not mechanically locked into position, block the load before servicing the system to prevent falling or drifting. Many pneumatic systems are controlled by electrical or electronic device. Before attempting service or repair on these components, be sure the electrical power supply has been turned off. Pneumatic directional control valves that use electrical solenoids to operate the valve spool are often equipped with manual overrides that can be used during troubleshooting to operate the system. Pneumatic lockout valve are excellent safety device that we can use properly on pneumatic system that can prevent accidental operations. Ensuring a safe condition should always be the first step in troubleshooting pneumatic system.
Our conclusion, if we can know how to construct accurately and can arrange the component of pneumatic circuit system, then we can know how to report and explain briefly the operation of pneumatic experiment in group. Next, we can learn to find out the correct component and equipment. For our recommendation, there are components that have been damaged mixed with the component that can work. For our recommendation, there are components that have been damaged mixed with the component that can work. Components should be separated so the student do not use the component to build the circuit. Component need to replace with a new component so we can use enough component to build the circuit mainly used by many groups.